Okay. So first question, what aspect about either the it's the pedal. What aspect about the pedal am I showing, and what could you write the equation of the graph? So can you write this function and explain what the input and output is relative to the pedal? Okay. Okay, what is being graphed about the pedal? Write a function. You got 30 seconds. Okay, Michaela, how'd you do? First question, so what aspect about the pedal is being graphed there? Cycle at which the pedal is moving. But what quantity is being graphed though? What particular quantity about the pedal is being graphed? Not quite. Yeah.
Fraction of the radius length to the left of the vertical diameter.
He said fraction of the radius length to the left of the vertical diameter.
To the right. Oh, to the right.
He went to the right, he wants to change it to the right. So he wants fraction of a radius length to the right of the vertical diameter. Agree? Yes, it's giving horizontal position, right? It's showing horizontal position of that pedal. And write the function. Joshua, you know what function this would be?
Cosine theta.
He wants cosine theta. Okay, got it. All right, so this is, and so we could call it, say, F. Okay. It's showing the horizontal position of the pedal in fractions of a radius length. Well, actually, I didn't give you a scale. So it could be, this could be, you know, whatever this is, what, like 16 centimeters. Maybe the pedal, maybe this is 16, because I didn't give you a scale. So it could have been showing it in, say, centimeters to the right of the vertical diameter, okay? Or fraction of a radius length. There's no scale there, so you can't know. Okay, so now I'm gonna write a new function up here. I'm gonna say it's g of theta equals and I want you to let's do it the other way now. I want you to identify what everything is in this context. So what quantities in regard to the pedal and the tire valve do each of these symbols represent? So what quantity does theta represent? What quantity does theta minus pi over 2 represent? And what quantity does cosine of theta minus pi over 2 represent? Okay? So all your answers will be with respect to the situation. the bicycle. Okay. Talk to the person next to you, compare what you got. So see if you agree with the person next to you. What do each of these mean? What are those quantities related to this scenario? Okay, Wyatt. Theta. Tell me about theta. What do you think that is?
The angle measure?
Angle measure. Well, is there only one angle measure up here? There's actually
Angle measure of the bipedal, sorry, the 3 o'clock position.
angle measure. He wants the angle measure of the pedal. Angle measure of the pedal. Swept counterclockwise from 3 o'clock. Agree with that? Yeah, because I wrote it on the screen, right? Angle measure of the pedal swept counterclockwise from 3 o'clock position. All right, theta minus pi over 2. Sarah, what do you think this is?
I think that one is the angle measure of the tire valve
Okay.
after it's swept counterclockwise.
So she wants angle. So everything's the same except it's the tire valve. Everything's the same as theta, but it's the tire valve now. So angle measure of the valve swept from counterclockwise from 3 o'clock. Does the picture show that? Is that what the animation is showing? How does it show that? How is the animation showing that? Kenneth.
Because the tire valve is behind the pedal.
The tire valve is behind the pedal. How far?
Pi over 2.
Right. The tire valve is behind the pedal by pi over 2. So it's lagging behind, right? It's lagging behind. All right, what about cosine of theta minus pi over 2 then? Cosine of theta minus pi over 2. Walden.
That's the horizontal distance to the right of the vertical diameter of this tire valve.
The horizontal distance to the right of the vertical diameter of the tire valve. Right, because it's cosine of this tire valve angle, right? Cosine of the tire valve angle will give horizontal position of the tire valve. Okay, so if it's lagging behind, the question is, what will that graph look like? So I'm going to put both, I'm going to cosine theta on both. So that's cosine theta on both. What will g of theta look like? If you were to sketch g of theta over there, what would we say? We said the angle is lagging behind pi over 2. So if it's lagging behind, are we going to shift left or are we going to shift right? Lagging behind for increasing theta. First the pedal angle starts, then pi over 2 later, the tire valve angle starts. So it shifts to the right. Should make perfect sense. That subtracting makes the angle lag behind, means it starts later. Should makes perfect sense. Pi over 2 is when the tire valve starts its cycle from 3 o'clock. Okay, any questions? All right, so I want to show you something here. Stop this. I still want the axes. The axes. Guess it turns off the axis when it's at 0. Okay, so look at that red graph. Here, let's turn it out this way. There we go. That's what I want. So look at that red graph. I'm going to take that red graph and I'm going to... So really, its horizontal position down here was what? So at theta equals 0. Right now we're at theta equals 0. What's the horizontal position of the tire valve? Negative pi halves. The horizontal position is negative pi halves. Okay, all headphones and all screens are closed today. Everyone's going to pay attention to the front. Close your screen unless you're taking notes. And Jerome's going to walk around and make sure if you've got your screen open because you're taking notes in class. And everyone's going to take their headphones out. Okay, so what's happening here? What's the horizontal position of the tire valve right here at theta equals 0?
0.
You should say 0. The horizontal position at the bottom is 0. So when theta equals 0, we're here. So for this first quarter rotation, I could continue that graph like that, right? And we know that this is, g of theta is cosine of theta minus pi over 2. Notice anything? What's that, Danny? He says it's the sine graph. Is it the sine graph? But I thought we were keeping track of horizontal position. Is this a true statement? According to what you're seeing, cosine theta minus pi over 2 is sure looking a lot like sine theta. But I thought G was tracking horizontal position. How could it be sine? Any comments? Yeah.
Is it the sine graph of theta?
What's that?
The sine graph of theta.
Yeah, sine of theta. So what we're seeing here is basically any one of these curves could be a cosine graph or a sine graph with the right shift. Okay? So yes, cosine in its origination for us meant horizontal position. But now any cosine graph that you write, you can also write it as a sine graph. Does it now mean vertical position of the tire valve? No, it still means the horizontal position. It's just written as a sine graph. It's just written as a sine function. Okay, so the original meanings of cosine and sine, cosine is horizontal position, sine is vertical position. But now that we're modeling real-world situations, anything that's sinusoidal can be modeled with both, with sine and cosine. This is a really important point. Is it okay? So why? Because sine and cosine are just a matter of shifting pi over 2 from each other. So if we graph both sine and cosine on the same graph, let's see. How can I do that? Let's see. Look, so here I'm graphing cosine theta as the blue one, and I'm graphing sine theta as the red one. They're the same graph, they're just off by pi over 2. So we know how to shift horizontally now, and so we can write any cosine graph as a sine graph with the right shift, or the proper shift, and then we can write any sine graph as a cosine with a proper shift. Okay, so we could write, in this scenario, you can write the horizontal position of the tire valve as sine theta. It works because it's the same as cosine of theta minus pi over 2. Okay, important point. Doesn't make sense. Okay, so you had one of those in your homework, and let's see that. The last one. So it says small Ferris wheel for kids turns counterclockwise and takes 4 seconds to make a full revolution. The radius of the wheel is 2 meters. The bottom of the wheel is 1 meter above the ground. T equals 1 second. After timer started, the rider's at the highest point on the wheel. So first thing we need to do is take this given information and make a sketch of it. And then once we have that sketch, then we know we can write it. So is it tracking vertical distance or horizontal distance? The rider's height above the ground. That'd be like vertical distance, right? But now we know we could write that as sine, and then we could also write it as cosine. We can write it as both. Okay, so let's make a sketch and see which one it looks like. So the bottom of the radius of the wheel is 2, the bottom of the wheel is 1, and where's our strategy here? Strategy, here's the strategy I recommend. Okay? Midline first. So the midline comes from knowing the max and the min. What's the max and what's the min? What's the max? 2. 2 is the max height of a rider. 5. All right, so let's draw a picture to set it up. What does it say? It says the bottom of the wheel is 1 meter above, right? And then the radius is 2. So that's halfway up, and then another halfway up gets us to the highest point. See that? Max is 5. Min is 1. Midline then is 3. Okay, the midline is not 1. That's how high the bottom of the wheel is up, but the midline would be how high the center of the circle is. So our midline's going to be at 3. Okay? And then it says it takes 4 seconds to make a full revolution. So we know we can divide by 4. So 1, 2, 3, 4. And it says at 1 second, the rider's at the highest point on the wheel. So what's the output of this function at 1 second? What's the output of this function at 1 second? Riley, what will be the output at 1 second?
1 second, the output would be 5.
He wants 5. And it's turning counterclockwise. So then at 2 seconds, what will the output of the function be? Elon? No, sorry.
The output of the function is 1.
At 2 seconds, he wants the output to be 1. What do we think? Agree with that? So the period is 4, right? The period is 4. So every quarter period, or 1 second, is it going to make it all the way from the max to the min?
I'm sorry.
It'll be 3, right? So then at 0 seconds, so it is top of the circle, then where on the circle is the rider now? Right here. 6, 3, 12, or 9? Top of the circle going counterclockwise. 9 o'clock position, left side. Then 1 second later, bottom of the circle, going counterclockwise. So this is 1 second, right? 2 seconds, 3 seconds, 4 seconds. What about at 0 seconds? Where will he be at 0 seconds? What will the output be? 3. So this is a sketch of what the information they gave us. Counterclockwise. Counterclockwise such that at the top of the circle, will be 5 meters up at 1 second. Questions on being able to do that? So this is a really important skill that you can get the right points in the right places and then sketch that curve correctly. All right, so then which one of those is the one that's given here? So we know it's going to go at 0, 3, then 1, 5, then 2, 3. 0, 3, a bit smaller now. Which one is it? 0, 3, 1, 5, 2, 3. Yeah, looks like this one. So this is the graph that matches the one we drew. Okay? That's the one that matches what we drew. Okay, so now we want to write this as a sine or cosine. Let's do the easier one first. So what will be easier, sine or cosine? Sine. But what is it measuring? What characteristic of the rider is it measuring? Horizontal distance or vertical distance? Still measuring the vertical distance, but because of all the other factors involved here, it ends up looking like more naturally a sine curve. But it's still, that thing is the outputs of those function. The output is the vertical height of the rider. Okay? So we're going to write it as a sine function first. So we've got here's our strategy, midline. Okay, what's the midline? 3. What's the amplitude? 2. It's the distance from the midline up to the top. Okay. All right, we get the period, and then from the period, it gives us this number b in the equation, right? So what is the period? What is it? It's about the input, right? Our input is in theta or seconds? Time, right? So our period is going to be whatever the input of the function is, 4 seconds. From 4 seconds, we need b such that 4 seconds in the input, so we need b such that 4 seconds of input gives us what angle measure? Should make sense. What coefficient times 4 seconds of interval will result in 2 pi of angle measure, so that will be the right coefficient so that the period is 4. So what will it be? Pi over 2. 2 pi over 4. And we're going to do it as a sine. And so if it's as a sine, then how much is it ahead or behind sine? How much is it shifted if we choose sine? This way. No shift. It is sine. There's no shift. It starts at the midline, goes up to the top. That's what sine does. So we're ready to write it. We got everything. What's A? Helps. Everything still shows up. So A was. See if this will work. No. Just want to move it over. Oh, brother. Okay, that's good. So sine is going to be 2 sine of b is pi halves. T is the input. We don't have a shift. And then the center line is, midline. It's not 1, right? It's not 1. The bottom is 1. We got to get the midline of the graph up to the midline of the wheel, which is 3. Okay, we'll come back and do it later. All right, so how about there we go. All right, now we want to do it as a cosine. So we want the exact same set of output values now written as a cosine. What's the amplitude or midline? 3, amplitude. 2, period. 4, everything here is the same. All right, so the midline's the same, amplitude's the same, period's the same, so the value of b is the same. So now when we write it as cosine, we have to figure out our graph is it ahead or behind? So what you can do is sketch cosine, which starts at the min, the mid, or the max. Max. And then at 1 second, it'll be at the mid. So sketch this cosine graph. Okay, and then we're asking, what are we asking? We're asking our graph. Is it ahead or behind in angle of a true cosine graph? Is it ahead or behind? Okay, I got both. So
Cosine is
Okay, I'm glad you said that. When you're doing this ahead or behind thing, you never compare a cosine to a sine. Never compare a sine to a cosine. Always compare the graph you have, if you're trying to write it as cosine, to the cosine graph. And if you're trying to write the graph that you have as a sine, you're comparing it to the sine. Never compare cosine and sine. It becomes confusing. So we're going to compare the graph we're writing as cosine to a cosine without a shift. Okay? So here's the cycle starting at the top, going down to the min, back up to the top. So the closest cycle that we can find here is here. Starts here, ends here. Standard cosine starts here, ends here. So our graph, if we look at that cycle right there, behind or ahead in angle? Starting later or starting earlier? Starting later, so it's behind. So what's the angle? Or t. So t is going to be? First of all, how much is it behind? Pi over 2. Really? Yes, in angle, but that's not what our input is, right? It's in seconds. So it's behind by 1 second. So our argument is going to be t what? Plus 1 or minus 1? I hear both. Does it start 1 second before or 1 second after? It starts 1 second after. Here's the standard cosine. This one is starting 1 second later, after. T minus 1 or t plus 1? Minus 1. Okay, let's put it in. Ready? So it's going to be, in cosine, it's going to be 2 cosine of pi halves. Now, times parentheses. Need parentheses here. It's important. T minus 1 plus 3. Okay, so I hear it kind of like restlessness, like boredom. That's what I'm feeling. So we have to go through this slowly because these are hard. Okay, there's lots involved, and you've really got to know everything. If you have one thing wrong, then the whole thing is wrong. You have a different graph. So try to stay in touch.
Just a quick question.
Yeah.
Format. Isn't the t supposed to be multiplied by the numerator? Like, isn't it supposed to be pi times t divided by 2?
Well, order of operations, right? So when you have division and multiplication, it's just going to go from left to right. So it's going to go pi, it's going to divide by 2, and if you knew multiply, it's going to just take that result and multiply it. If you wanted that in the denominator, you'd have to have another set of parentheses there. But you're right, it is on the top. Okay. So, did we get it? I didn't submit the graph, but we can see about those two equations. We got them. Okay? Anybody have a question? So I'm going to put you to work now. We got 2 examples for you guys to do. Yes?
It was, I think it was in the previous problem. It was saying unshifted compared to unshifted.
Like when I sketched the cosine, unshifted, right? It's like a sine or cosine unshifted. That's what you compare to the one you're trying to build.
No, that makes sense.
Yeah, like when I sketched that black, that was the unshifted cosine. Yeah. Okay, here we go. Oh, I get the wrong one, no wonder. Okay. Be as light as possible. Okay, I guess that's good. All right, so here's the graph you're going to write both as a sine and a cosine. So when you look at this, is this graph modeling the vertical height of something or the horizontal position of something? Is it modeling the vertical height of something or the horizontal position of something? No, it could be either. You can't tell. That's the point. We just saw examples of how it looked like a sine, but it was giving us horizontal position. Both sine and cosine can model either one with the right shift, with the right what's called a phase shift or the right input shift. Okay, so without any context, you don't know. It could be representing a vertical position or a horizontal position or something else. All right, so something else that's not going in a circle. It's just repeating. Okay, so the first question is, when you get to part B here, or when you get to the period, you have to recognize whether it's based on a pi scale or an integer scale. So it can be both. So here I'm showing on the axis right now, I'm showing pi scale. So the grid lines, this is pi over 2, and then this grid line is pi, 3 pi over 2, 2 pi. And then this is that's an integer scale. So all these grid lines are on the integers, whole numbers, whole values. So the graph, the first thing you have to decide when you're working with the period is it based on a pi scale, like this? Or is it based on an integer scale? So like that last, the Ferris wheel one. Was it based on a pi scale or integer scale? Was it? It was seconds, right? 1 second, 2 seconds, 3 seconds, 4. It took 4 seconds to get around. So that was based on a integer scale. What about this? Integer or pi scale? I'm showing the integer scale here. Does it match up with the integer scale? Yes. So I'll leave that scale up there for you to work on this. Here's the strategy. Okay, and you're going to write it both ways. Okay, you're going to write it both ways. You're going to write it as a sine and write it as a cosine. Okay, Faisal. Let's start. How about the midline of this? Did you get the midline? Nice and loud. You said? -1. Amplitude. 2. What's the period? According to the graph, what's the period? Walter, what do you think? What's the period?
I said 3.
You said 3? So from 0 to 3 is when you get one full cycle.
Yeah.
So here's starting the cycle. It's going up, right? And then back down. When does the cycle start over? At 3? At 2, right? So the period is 2. And so then we're saying what coefficient times our period will give us an angle of, so B is, so we've gotten pi. Do the easy one first. Sine or cosine first? Sine. So if it's, and what is the unshifted sine? How does it compare to our graph? Unshifted sine, how does our graph compare to it? It's the same, right? So this is unshifted sine. We don't have to worry about a horizontal shift. So as a sine graph, we're ready to write it. 2 sine, what's our B? Pi times x. Yes? Is that what we came up with? Okay, as cosine. So same function, but now as a cosine curve. Everything's the same except there's going to be a shift. So we can just start like that, and all we got to do is figure out the shift for cosine. So we sketch the unshifted cosine, which is going to start at 0 where? What output will the output of unshifted cosine be at 0? 1. And then in a quarter period, it'll be at -1. This is our unshifted cosine, and then it'll be at -3. Something like this. So you look for there's different shifts you can do. There's an infinite you can do, but just look for the closest one. So the closest one is right here. So then our graph, we're asking, our graph, is it, if we look at from there, the cycle from there to there, versus the unshifted from here to here, is our graph ahead or behind? Our graph, she said our graph is behind. Agree with that? Yeah. How far behind is it? 0.5 seconds or whatever this is. 0.5. So this right here, our graph starts 0.5 later. So if it's later, we're going to do x what? Minus 1/2. There they are. Okay, I could check them. I could put these in and see if it lands right on top of it, and it will. Okay? So one more practice problem. Or at least one more. Maybe we'll have time for 2. Questions on this one? Are we good? All right, let's change it up a little bit. Okay. So first thing, got to decide. Is it based on a pi scale or integer scale? So right now I've got it on integer scale. Is it on integer scale or pi? Leave it or change it? Leave it. Go. Both of them. Sine, cosine. Go.
It's a good start.
Okay, Derek, you're up. Midline. -2. Amplitude. 0.5. Period. No, the period. I want the period. Period is, so if we could start here from 2, when does it return to there? 8. So the period is 6. Okay, so the period is 6. So what do we need? We need the coefficient that when the input reaches 6, the argument reaches 2 pi. We need the coefficient such that when the input reaches 6, we've done an angle of 2 pi for one full rotation. So B is pi over 3, 2 pi over 6. Okay, so first of all, we'll do it as sine first, okay? Is there a shift if we do sine? Yes, so we're going to sketch the sine. So at 0, where's the sine going to be? Min, midline, max. Mid. And then in 1/4 period, it goes up to the max, and then back to the quarter period is 1.5. Gotta be careful. Okay, so quarter period is here, and then back to the there, and then 4.5, and then 6. There's unshifted sine. So the closest one looks like I didn't show you. This is going to be bad. So we can just do this. Use the one you can see. So here's the closest one that you can see. There's one back here you could use, but you can't really see where it hits. So our graph, ahead or behind? So it's going to be what, by this much? Our graph, ahead or behind? Unshifted sine. Behind, how much? 3.5 behind. It starts 3.5 later. Okay, you could also have done, I think, 2.5 ahead, but I didn't quite show it to you. So here at 2.5 is at the midline. So you could have done this cycle and said, oh, it's also 2.5 ahead. And that would give you the same graph. There's many ways to write these. Okay, so we're ready to do it. F of x equals amplitude 0.5 sine of pi over 3 times x behind minus 3.5. Or you could have plus 2.5 if you figured that out. And then minus 2. Okay, that's the sine. Cosine. Everything else is the same except the shift. Same period, same coefficient b. Same vertical shift, so we just got to figure out if it's cosine. So sketching the unshifted cosine, it's going to look like this. So the black one is unshifted cosine. Closest one starts here. Ahead or behind? Ahead by how much? Ahead by 1. So you could do plus 1. Okay, so we have our next exam a week from today. Normal homework for Monday and Wednesday.